Hello, my name is Sang-Kyung Lee, graduate student from SKKU, South Korea. I'll introduce MelBERT, metaphor detection via contextualized late interaction using metaphor identification theories. This work is done with Minjin Choi, Eun-Sung Choi, Hee-Soo Park, Junhyuk Lee, Dongwon Lee, and Jong-Wook Lee. First, metaphor detection. A metaphor is a common language expression representing other concepts rather than literal meanings. For example, for the sentence, "The debate has been sharpened," the word sharpen does not literally mean to make something sharper like a knife or a pencil. It is a metaphorical expression to describe that the debate has become more intense. The metaphor plays a crucial role in cognitive and communicative functions. Also, it is essential to understand metaphoricity in various natural language processing tasks. A lot of existing studies have developed various computational models to recognize metaphor based on the approach as follows. Firstly, feature-based methods are intuitive and straightforward, but it is challenging to handle rare usages of metaphor if the word or phrase is not annotated beforehand. Also, several studies propose neural metaphor detection using recurrent neural networks. This approach can consider sequences of words, but it has limitations in representing various aspects of words in context, only with the shallow neural networks like bidirectional LSTM or convolutional neural network. For our work, we utilize a pre-trained contextualized model using two metaphor identification linguistic theories, allowing the model to have a rich and powerful representation capacity. Also, we effectively utilize two metaphor identification theories based on the powerful representation of the pre-trained contextualized model. For SPV, which means selectional preference violation, a metaphorical word is identified if the target word has any contradiction between its contexts. For example, in the sentence, "The debate has been sharpened," it is unusual for the word sharpened to be in the context of debate rather than a pencil, thus identified as a metaphor. For MIP, on the other hand, an abbreviation for metaphor identification procedure, a metaphorical word is identified from the difference between its literal meaning and contextual meaning. In the example sentence, contextual meaning of the word sharpen is different from its literal meaning in the sentence, thus identified as a metaphor as well. For our work, these two theories are fully utilized for metaphor detection. Also, we leverage late interaction architecture with the contextualized representation. It enables the model to prevent unnecessary interactions while effectively distinguish the contextualized and literal meanings of a word. Based on the motivation, we propose a novel metaphor detection model, namely MelBERT. MelBERT is based on the SPV layer and MIP layer. And let me explain each component. We use SPV layer to identify the contradiction between a target word and its context. The input of the encoder is the sentence, and VS and VST are the embedding vector, each for the CLS token and the target word. Given a target word in the sentence, sharpened in the example, our key assumption is that the VS and VST show unusual context if the target word is metaphorical. This is because VS represents the interaction across all pairwise words in the sentence, while VST represents the interaction only between the target word and other words in the sentence. Next, MIP layer identifies the semantic gap for the target word in context and isolation. VST is a contextualized embedding vector for the target word, representing the interaction within the sentence. On the other hand, VT is an isolated embedding vector for the target word. We identify the metaphorical word with the semantic gap with these two vectors, that represents contextualized meaning and literary meaning. Using the two strategies, we combine two hidden vectors, each from SPV layer and MIP layer, to compute a prediction score. Lastly, MelBERT predicts whether a target word is metaphorical or not. In detail, we use the cross-entropy loss function for binary classification. We also utilize linguistic features like POS tags and local context for the encoder's input. The local context indicates a clause including target tokens if the sentence is in a composite sentence. For this section, let me explain the experiments of our work. We use well-known public English datasets, VUA. We evaluate models for two versions of VUA datasets released for metaphor detection shared tasks, each in 2018 and 2020 by VU Amsterdam Metaphor Corpus. We compared our model with strong baselines, including 4 RNN-based models and 3 contextualization-based models. The table shows the performance of our model. It is found that MelBERT consistently outperforms competitive models over 2 benchmark datasets in terms of F1 score. MelBERT exceeds DMAT with 1% and 2.8% performance gains on the 2 datasets. And MelBERT also outperforms contextualized baselines, indicating that MelBERT effectively utilizes metaphorical identification theories. To better understand the performance of MelBERT, we conducted various analyses. In this presentation, I'll briefly go over 3 analyses. First, in terms of comparison results for 4 post tags, MelBERT shows the best or comparable performance over baselines in terms of F1 score. MelBERT outperforms RNN-based models with 3.4% to 14.5% gains. For all post tags, MelBERT also shows performance gain over DeepMAT, which means that MelBERT can achieve consistent improvements regardless of post tags of target words. We also experimented to identify the effects of 2 different linguistic theories. It is found that MelBERT, using both strategies, consistently shows the best performance. Also, MelBERT without SPV outperforms MelBERT without MIP, proving the effectiveness of the late interaction mechanism. Lastly, here is the qualitative analysis of MelBERT. It is found that MelBERT detects metaphors that other models like MelBERT without MIP and MelBERT without SPV do not notice. In conclusion, we propose a novel metaphor detection model with a good theoretical foundation of linguistics, namely MelBERT. Also, MelBERT achieves competitive or state-of-the-art performance on various datasets. This is the end of my presentation, and if you have any question, please contact me via email. Thank you for your attention.